Okay, hi everyone. So this is a question that comes from the Winter 2013 paper. So in this question, we're given the expression of y with reference to x as y equals to k squared over x plus 2 plus x, where k is a positive constant. In this question, we are required to find the values of x, where the curve has stationary points, and also to determine the nature of the stationary points, meaning whether it's a maximum or a minimum. Prior to this question, I've actually drawn a specific curve where k has the value of 1. As you can see in the curve, there are two turning points that you can actually notice here, which you can attain by doing dy per dx equals to 0, meaning at those points the gradient is equals to 0. Okay, so first what we need to do is differentiate our equation. So we have y equals to k squared x plus 2 to the power of negative 1 plus x, and if we directly differentiate it, we actually get dy per dx equals to k squared, k to negative 1, x plus 2 to the power of minus 1 minus 1. Okay, and since the coefficient of x here is just 1, so I don't need to worry. And on this side, we have x, so differentiation of x will be 1. Okay, so then this equation becomes negative k squared over x plus 2 squared plus 1. So let us now find the turning points. So when dy per dx equals to 0, that means that k squared will be equals to x plus 2 squared. Okay, and therefore when we square root it, we must not forget plus minus, so equals to x plus 2. So x will take on the values of negative 2 plus minus k. So we have actually two turning points, one where the value is equals to negative 2 minus k, and the other one being negative 2 plus k. Okay, so let's look at the nature of the turning point. In order to attain this, we actually need to get the second order differential. So d2y per dx squared, so be equals to negative k squared. So the differentiation of x plus 2 to the power of negative 2, this will give me negative 2 here, x plus 2 to the power of negative 2 minus 1. Okay, while I have a constant, it adds a constant, so differentiation of a constant will give me 0. So then this becomes k squared, 2k squared over x plus 2 to the power of 3. So let's look at the two turning points now. So when x equals to negative 2 plus k, what we attain for the second order differential is equals to 2k squared over k cubed. So we actually have this as a positive value, so therefore this means that at that part of the curve where x equals to negative 2 plus k, this will be a minimum. Okay, so when x equals to negative 2 minus k, so we have the second order differential value x as 2k squared over negative k